let's talk about sequence containers. Okay. Here are 4 different sequence containers. Okay. A sequence container allows you to control the order in which something is stored. Okay. The order does not depend on the values of the elements contained within it. Okay. So we have a vector. We can insert an arrays from either the middle or the front or back. The time required to insert into a vector depends on where we're inserting. A doubly linked list allows you to insert at any position, but only to receive something from the front or the back. You don't have random access, which means that you can iterate over to find something in the middle, but you can't just arbitrarily go straight to that location. A vector, you can just go straight to a middle location. Okay, so a vector for going to random access, going to the middle or something, is very fast. A list does not even allow you to do that. Okay, a forward list, a singularly linked list, okay, only allows you to access the front, doesn't allow you to access anywhere else down it. Okay, but you can insert anywhere along the list. And a double-ended queue does allow you random access, okay? And it's got a very similar insertion and erasing time to a vector, okay? And you can work out the rest for a stack, a queue, and a priority queue yourself, okay? So I've probably mentioned vector about 20 times already. Vector is the most common thing you're going to go and use, okay? It's defined inside the header file vector, so hash include vector, okay? Essentially, it's a dynamic array. Its elements are stored sequentially in memory. Okay, you have very fast access to elements. Insertion and removal at the end is very fast, but insertion and removal in the middle is very slow. Okay, and so you've got some code there. Again, that should have standard up on the front of vector and standard up on cout in line. Okay, but vectors are generally pretty fast, except for if you want to go and insert stuff and delete stuff from the middle. Here's all the constructors for a vector. And there are a lot of constructors. Again, they serve different purposes, and again, you can go look for documentation for these. Okay? But you can have vector v0 be list initialized to 1, 2, 3. First 3 elements in that vector are elements 1, 2, and 3. The second one there, vector v1, is a vector of ints, but it's got nothing inside it at first. It's empty. Vector float v2 contains 5 elements, all initialized to 1.0. Okay. Now I don't expect you to remember all these different ways of initializing things. Okay. But again, the documentation will help you out for this. But it's helpful to know which one to use, because again, the speed here is going to be faster than you manually going and inserting stuff. Okay. The fourth one there for vector of doubles v310 makes it 10 elements in size, and they're all defaulted to zeros. Okay? You've got a copy constructor there taking in v2. Okay, so remember v2 here was a float, this is a double, you've got type promotion going on, so you've got some typecasting. Okay, but that's fine. What about this one? Vector of string. Hello world. How many elements are in this vector? Should be easy. How many elements in this vector? 2. Yep. Cool. You got 2. You don't have 10. It's not each character's gone in there. You got the 2 strings. Okay. You then have int a 1, 2, 3. Okay. That's probably awfully confusing. That int a 1, 2, 3. Okay. I'm surprised you can do that. That's pretty horrible code. Okay. But that works for some reason. You could then create a vector of elements. Actually, that should be an array. That's a bug in the code there. That should be int a with array-sized thing there. Okay, but you can say a to a plus 3. Okay, so that just uses your pointer arithmetic. So if that int a was actually an array of ints, okay, you can also use iterators. So here in v6, we're saying int here v2 was a float. We're saying get the starting point of that vector, get the ending point of that vector, and iterate over that container and copy that data across into here. Okay? So everyone understanding the different types at this point. Again, you don't really need to understand the code, it's more understanding the ideas behind what's going on. Okay? Now, for bottom one, the vector node default constructor giving you the error. Okay? No default constructor is a type. We have to find a type. Okay, we've defined a type, it doesn't exist. We have to define a type called no default constructor. That means that this type, this class, cannot be constructed without giving it some additional data. Okay? We've then asked it to create a container of these things without default constructors, a container to hold 10 of them. Why does this error? Haven't given it a default value. Okay, so that's not going to work. This no default constructor version doesn't work. Okay? So even though you've got all these different vectors, all these different constructors, for the vector itself, it still is type dependent on what it's storing, which one of these constructors you can use. Okay? We can also have vectors of pointers. We can have vectors of vectors. Okay, there's our two-dimensional array. We can have vectors of other containers. So a vector of a map, the map contains a string and a list of ints. Okay? You could also have a vector of list pointers where the list pointer is a list of strings. Okay? This is all completely fine. If you're writing code like this, just be aware of what you're doing. Okay? This is where its documentation is important, making sure you comment your code about which things you're actually trying to do here. Okay? Okay. So accessing vectors, I've already mentioned some of this, but you can use the square brackets to access elements without any runtime check of index. Okay? That means if you try to go over the bounds, the index becomes undefined. The behavior is undefined. It's not guaranteed that you'll get an error or not get an error. It's undefined. It will depend on your compiler. Okay? The at function does the same thing as indexing using the square brackets there, but it's safer. It's slower but safer because it throws an exception. So you might have try catch. If you're coming from Java, you should know about try and catch already. Okay. But if you try to, you've got words here, hello world. You've got 0 and 1 index. If you try to say word at position 2, it throws an out of range exception. You can catch that. Okay. Again, we'll talk more about throwing and catching exceptions in week 4. Okay. But be aware that you can do these sort of things. Okay. And again, this is old code, so it's missing all the standard namespace stuff, but you should be able to figure it out. Okay. So a vector can be pre-sized, so at compile time. It can be given a size at construction. Okay. Now the difference between this and an array is an array you need to give it a fixed size at compile time. At compile time for this, you could give it an int I with a variable for how big it wants to be pre-sized to, and that will work. Okay. You can also ask it how big it is by just calling .size. Okay. There's also the notion of .capacity. .capacity is how big can it get before it has to be resized in memory. Okay. And so, as you can see on the right-hand side, you have the size notation, that's the number of elements in a container, and capacity, how much it can store before it gets resized. Okay? And there's some code here about how to break it. Okay? So you can see there's a capacity of 0, and there's nothing stored inside it, because v.size is 0 as well. Okay? Then if you try to assign, okay, so if you try to assign value 1 into position 0, even though it's got nothing inside it, this will give a segmentation fault. You can't random access like this. But you can say v.pushback 1, and that will put 1 now into that position 0, push it back, it'll work fine, okay? And that allows you to run, okay? So you really shouldn't be doing any of these square bracket things at all, okay? They're left over some C, okay? You should be ideally doing everything through the member functions. Okay. Let's look at using a sign. Okay, so we're still focusing on vector at this point. Okay. We have v1, a vector of ints, v2, a vector of float. We cannot assign v1 to v2 because that's a vector of ints and that's a vector of floats. They are different types. Okay? But we can do this. Vector 2, okay, still being a vector of floats, dot assign vector 1 dot begin iterator 2 dot end iterator. So iterate over the entire collection of what's inside vector v1. Okay? This typecasts everything in vector 1 into a vector 2. So it promotes from an int to a float. Okay, that's fine. You can do that. Okay? So again, notice the difference in the style of the notations here. This old style is v2 equals v1. Doesn't work. v2 dot assign, you're being very explicit about what you're doing. You are saying, I know what I'm doing. I want this thing to be typecast at this point. Okay? And it allows you to do that. Okay? This one, we create a list of ints. Okay, so this is a list now, not a vector, list of ints. Okay? We then assign, okay, so it's going to be a list of 20 ints all being 0. We can assign from that list into that vector because we're using the iterators. Okay? So there's no way we could say for vector and the list are equal. We can't do the assignment that way, but we can use the iterators to call the dot assign over here on line 13, and it works. Okay? Because the iterators are the glue between the containers. Okay? But we can't do line 15 and line 16. We can't create a list of strings, 20 strings all saying hi. We can't assign them into the vector v2 because we can't do for typecast from the string to the float. Remember that v2 was a float. This v4 is of type string. You cannot do that, okay, because that doesn't make any sense. So into the float was fine because you can typecast that way. Cannot do string to float. There's no definition of what that typecast is. So even using the dot assign, you would have a problem. What about insertion and removal? Okay, so we can create a vector of words, hello world. We can then say push back C++ on line 3. And our container now contains 3 things, hello world, C++. We can also pop back, and what that means is we lose the last element. Okay, should be basic. Okay. And to insert into the middle, we have a vector of words, hello world. We have this particular type here. Vector, string, colon, iterator. Okay, and again, unfortunately it's missing from the slides, but it should be standard in front of these things. Okay. Words.begin, get us for iterator to the first thing. Okay. When we say words.begin, when we say get us for iterator, we do, for iterator is not of type string. And we're very clear about that. The iterator is not of type string. The iterator is also not of type vector. The iterator is of type iterator. The iterator is of type standard colon vector, standard colon string, colon iterator. That is your type for the iterator. This is why a lot of people use auto, okay? Because otherwise remembering all that's confusing. Auto will do that, work that out for you. Off your iterator, not off your vector, but off your iterator, you can say words.insert ++i, okay, so remember, sorry, words is a vector, insert, ++i, so pre-increment I to the second position, insert the string lovely. Hello lovely world is now in our container. Words.erase takes an iterator and removes one element, whatever the iterator is iterating to or referencing or pointing to. So words.begin is the first element. Words.erase, words.begin removes the first element. Okay, so now our container contains lovely world. That should be obvious, hopefully. Okay, so these iterators are powerful things. Okay, so we're clear about vector. Gone quite slowly through some of these things. And again, if you think I've gone fast, go back, reread over these slides, and go read the textbook on this stuff. So what other containers do we have? in terms of sequence containers. We have list, okay, which I've already said is a doubly linked list. There's no method for randomly inserting, okay, but there is support for fast merging and splicing of this, okay. So this hello world, we can splice. We can get words.begin ++, okay, so move to the second location. Splice or insert words2 into there. And for splice is basically what we call a destructive read for words2. It takes the components in list word2 and places them into middle words 1, or just words in this case, and words2 is now empty. Okay? So it's a destructive read for words2. It goes and modifies words2 and words1 as splice. Okay? But that's very efficient because it just moves the pointers around. Okay? Very, very efficient. If you tried to do that with a vector, you'd end up having to resize the vector and it'd be very slow because you have to actually manually insert that stuff. Forward list, as I already mentioned, is a singly linked list. It takes less memory. It has a slimmer interface. It also has no minus iterator. Okay? What that means is with an iterator, you can go ++ to go to the next element. You can go minus to go backwards. A singly linked list, you can only go one way. You can only go forward. Can't go back. Okay? But you can still do the splice. Okay? The splice still works. Slightly different commands for how to do it, but you can still do the splice. Okay, what else do we have? And we've got a dequeue. It's a double-ended queue. It's like a vector, but it allows fast insertion and removal from the beginning as well as the end. Okay? So we can push front and pop front. Okay? We're also for array that we mentioned earlier. Okay, but for precaution about arrays is you need to know the size at compile time, even though it gets us some nice ways of being able to work with some of the C++11 type STL components. Okay, it's basically just wrapping a C-style array. Okay, use vector over array unless you really know that you need an array. Okay, what about adapters? Okay, so we've got stack queues and priority queues. They're basically just built on top of vectors or queues or whatever else that we need. Okay, they're just built on top of these things and then take away some of the functionality and give us some more functionality. So priority queue is probably a good example. Priority queue gives us an ordered queue, but it's based on top of a heap type structure. Okay, and it gives us its own custom API sometimes. So we've got the standard template library API. Okay, and so one of the things that's missing from these slides, we cannot call standard sort on a list because standard sort relies on random access. Okay, don't ask me why, it's just for design, it relies on random access. You cannot call sort on a list. But a list also defines its own .sort method to get around this. Okay, so the standard template library allows us to give a whole ton of generic containers and types and values and things like that. But then sometimes, for more custom ones, they then define their own custom versions of doing stuff. And we generally prioritize using the custom versions if they exist. Okay, so you've got this trade-off between standard template library designed for very, very fast usage of stuff, but if you're really trying to use a particular container, prioritize using its own custom versions of stuff over the standard template library. If they exist, you'll need to check for documentation for when you're using these things. Okay? You're also encouraged to create your own adapters and own versions of things based on STL containers.